Sinusoidal signals are continuous, or they don't stop from negative infinity to infinity. So if you take a sinusoidal signal and you take the Fourier transform of it, you will get omega naught to infinity. That's continuous. So what we do is that we take a window function and we multiply it by the sinusoid so we can cut it, okay? And then we take that Fourier transform, cutting that function, taking it to the frequency domain by the Fourier transform induces a smearing noise, reducing the sharpness, smoothing it or blurring it. You see, okay. In order to remove the calculation noise induced by the 2D Fourier transform, filtered Fourier transform process is used. The steps are simple. First, obtain the projection function, which is happening when you take I and you push it through a f of xy, which is an object. Okay, f of p of phi of r equals negative infinity to infinity f of xy ds, which equals to minus ln ir over I naught. Then we calculate the 1D Fourier transform of the projection function to get this p phi of kr, which is equal to this formula here. Then, finally, the most important one is to calculate the filtered back projection, which is k of phi of r. What is this? This is the inverse Fourier transform of the absolute value filter kr times the projection method that you converted to the Fourier transform to finally obtain f of xy, which is filtered. F of xy equals from 0 to pi k phi of r, the q phi of r. And why did we use this here? Well, this is to convert it back from the polar form back to the regular form or coordinates, because f of xy, you can see here, and you can see here that it's a q, it's a phi and an r. See, this is with respect to phi. So you are in the polar form right now and you want to go back to the regular form. As mentioned before, the projection method, you get it from taking I node, intensity node, and taking through an object, which will generate the f of xy. Then you will be in the polar form, which is p phi of r. And you see this? This is x of cosine phi plus sine phi, which is r. Why the r, you say? Since it is a q phi r, we are using the r1, which is x cosine phi plus y sine phi. That's it. We want to filter it to maintain its sharpness of the image, which is crucial when you are using this to classify structures in the body.